And I'll just start that again. Hello, everyone, and welcome to the first edition of our Meet the Engineer series of events. My name is Dr. Toby Elushakin, and I will be your host for this evening. This event is an opportunity for young students, school leavers, and degree holders to understand more about engineering, both in terms of the work itself and in terms of personal experiences. Like I mentioned, this is the first edition, so we plan to have more of these in the future, where other people, engineers, can come around and talk about their work and their journey. Before we move ahead though, we've got a few house rules to run through. Firstly, this event is being recorded, so those who are unable to attend this event live and those who are looking to revisit the event afterwards in the future can access it. The link to the CBD certificates for this event will be posted in the chat, so please look out for that. We've also got a survey for you to fill afterwards, and this will be included in the chat as well. Please use the Q&A functions to prepare your questions for our speakers. And the webinar should take between 45 minutes and 1 hour, and we expect and will try to keep to time. Our speakers are two young professionals, Dipendra Mistry and Jason Lee, both of them chartered engineers. They'll be speaking to us this evening about their journey so far and their experiences as engineers. Dipendra will be going first, followed by a Q&A session. Then we'll have Jason speak to us, and then followed by another Q&A session. So without further ado, please join me in welcoming Dipendra.
Thank you very much, Toby, for that introduction. I'm just going to share my screen so I can show you some information. Right, so hopefully you can see my slides. Okay, so hello and welcome to this Meet the Engineer event. So my aim for this presentation really is to give you a very brief introduction into my career journey so far. I graduated in around 2013, so I've been working in industry for over 7 years, and I'm now doing a PhD, so I've gone into kind of the research and academia section. Before I start this talk, I just want to say a short disclaimer, and that is talking about success, and not just success in your life, but success in your career, wherever that may take you. And I think many people, when they're early in their career, think of success as a kind of a linear journey that you start in one job and you go through a few jobs and you become the CEO or something like that in a profession or in your career. But really, even when I look back at my own career, as you'll see, it does take many turns, some of which you can predict and some of which you can't. And I think that's what makes it all the more exciting and enjoyable. And I can promise you that if you take a career in STEM or in engineering in general, you'll have many of these twists and turns that will take you through to many exciting opportunities, not just in the technology and the products that you work on, but also the people that you work with. So I wanted to just take you through a rough timeline of when I graduated and the kind of jobs that I held along the way and what I learned through those. And then I'll touch on a few lessons that have helped me, and I hope that will help you as well in the future as you go through your careers. I guess the first thing to point out with my journey is that it's very unconventional from an engineering perspective, because I actually took a science degree. So my undergraduate was in physics. And at that time, I was enjoying the kind of science aspect, but I really wanted to move more into applied science, which for me, the natural next step was to take a job in engineering. So luckily, I found a graduate scheme. And at that time, it was at a place very close to me, at a company called Teledyne E2V. And I worked there as a graduate engineer. I'll show you a few examples on the next slide. So that was a 2-year scheme where I kind of rotated around the company doing different placements, working on things like image cameras or image sensors for space imaging applications, and also pulsed RF power for radiotherapy, satellite communication, and various applications like that. After completing the scheme, I was then promoted to a development engineer, where I stayed for a few years after that. And that was a really good experience to work in a large company and to get to experience many different aspects of engineering from a manufacturing perspective, design and test. I also became chartered in around 2015, so it was around 3 to 4 years after my degree. That was with the IET. So a few examples of some of the big projects that I worked on, focused on RF, so radio frequency energy. So think of this like the energy that you have in your microwave oven at home. So those devices are typically around 800 watts. These devices that I worked on were a few millions of watts, and they were pulse power. So what they were used for is for, in the case of radiotherapy, to accelerate electrons, if you look at the left-hand image, to basically collide with a dense target material to form X-rays. And these are used for treating cancer and also for imaging patients as well. So I got the opportunity to work on these kinds of technologies, which are really interesting to me. And the medical aspect was really at the heart for me because I was really interested in that from even my undergraduate days. I also got to attend a few conferences and work with sales and marketing teams and really just learn more about how to make products like these, some of the manufacturing issues, how to design them. And most of my expertise is really focused on testing these. And as you can imagine, testing something that works at millions of watts is obviously very dangerous, but also challenging because we had many thousands of volts that we had to deal with, and we had to earth that in a safe way. We had to cool it with many tens or hundreds of liters of water. So that was always exciting, especially when we had a water leak. So moving on from that, in around 2018, I was looking for a different experience, a different opportunity. And having worked for a large company, I really just wanted to go somewhere smaller. So I actually found a startup, funny enough, through a colleague of mine that I'd actually worked with at the first company. And that's a point I'd really like to emphasize. For me, the hardest job to get was my first real job, my first job after university. Ever since then, most of my jobs that I've managed to find or connect or network through were through people that I'd met in previous companies or through platforms like LinkedIn. So if you can really secure a firm position for yourself in your first job, it really sets you up well for the rest of your career. So moving back to the career journey, I went to work for a small startup called Phaser, and there they were working on satellite communication. So again, using radio frequency devices, but these were more in the form of antennas. They look something like this. So there are a range of different antenna types, which look like a number of elements on a circuit board, and we could build them up into larger arrays by kind of tiling them and test them in things called anechoic chambers. So I was responsible for a chamber that looked like this, and we could produce all sorts of radiation patterns of the antenna to make sure that we could send and receive the correct information and get the correct beam pattern. And this was probably one of my most exciting jobs for this reason, as you'll see on the next slide. So I got to make this cool room from scratch, which was like the size of a big living room. It's about 3 meters tall by 5 meters by 4 meters. We kitted this out from scratch. I was responsible for buying all the kit, and it was like having my own lab. So it was really great. And we also spent the Christmas party in there because it was so huge as well. So moving on from that, I also went to a smaller startup thereafter in 2020, where I was working on the same kind of technology, but leading a team. And then I wanted to do a pivot in my career where I wanted to go back into research and back into physics. And the reason for this was really the intersection of different technologies. So I learned a lot about RF, but I wanted to apply it again to the medical environment. I already had been to Nottingham for my undergraduate, and I really just wanted a change of pace in terms of my work lifestyle and also the technology that I was working on. And if anything, what I've learned from a number of the IET talks that I've been to over the years is that lots of the interesting stuff in engineering happens at the intersection between different disciplines. And I'm definitely finding that to be the case with the work I'm doing today. So I started this PhD earlier this year in April, and my research has been focused on MRI. In particular, this type of form factor of MRI called open MRI, where the patient can not just lie down, but also be seated or standing up. And this offers a number of unique insights because we can study the person under different effects. So we can look at their anatomy when they're sitting and standing. This is useful for patients who are suffering from long COVID because often they can't lie down to be scanned. Also people with gastric disorders of the stomach and the lower bowel. It's interesting to study them under gravity. And we're also doing studies for people with knee arthritis and sports injuries because we can better study the effects and physiology of them when they're in different positions. So this is a really interesting opportunity. It combines lots of my previous career experience and also gets me back into the field of medical physics, which is something that really interests me. So that all looks like an amazing body of work, and looking at it like that telling that story again, it does look like a straight line, but I promise you it wasn't. It was full of twists and turns and all sorts of confusing decisions. But if anything, I want to leave you with these kind of golden nuggets, if you will, or words of wisdom. And the four points are summarized here. So if you continue to work in STEM, or if you take a career in engineering, I can promise you that it's very rewarding. And for me, I really see myself as solving problems for humanity. And there are so many problems to solve in today's world in terms of climate change, the whole issue of energy, sustainability. There's so many areas that you could focus your career or your whole life's work into. And why not do that in a career like STEM? So I definitely feel like it's rewarding, and there's plenty of opportunities for you to work in. The second thing to consider is that with the way that people view their careers today, and also with the number of opportunities that are available because of businesses moving online and the way that we're working now in a post-COVID world, I would encourage you to think of your career not as a tree. So not as, you start off as a graduate engineer, then a junior engineer, then a senior engineer, X, Y, Z, but think of it as a ladder that doesn't just go up, but it also goes sideways. And I got this idea from a book that I read recently, and that's kind of what inspired me to consider doing a PhD. So if you think of your career as a long game, not a sprint, but a marathon, you can think about acquiring skills throughout your career, not just front loading your career with education at the beginning, but continuously educating yourself throughout your career. And this will allow you to take on opportunities that you might not have thought of before, and also lead you some unique insights. Number 3, become an IET member. So this was something I debated a lot when I finished university, and it's really been helpful for me in so many ways, not just to become chartered, also to build up a huge network of people that are running this webinar today, of which I was part of, the opportunity to volunteer, and also just to keep on top of and aware of all the other developments and exciting things that are happening in engineering outside of my field. And the final point to bear in mind is when you're thinking about your future jobs, your future careers, don't just think about the company, think about it in terms of this holy trinity, as I would put it. So having worked for large and small companies myself, think about the sector you're working in, oil and gas, renewable, startup, medtech, the type of company, big, small, startup, corporate, large corporate, for example. And also think about the culture. So is it forward thinking? Is it a culture that's aligned to your own values? And I'm sure that if you combine all these aspects, you'll definitely find a place and a company that you can work for where you really enjoy yourself and use it as a springboard for your career. So thanks for listening. If you want to continue the conversation on social media, so please feel free to reach out and connect and ask any questions by all means. And if you've got any questions now, I'm happy to take them. So thanks for listening. Back to you, Toby.
Thank you very much, Dipendra. That was a lovely presentation. Thanks for taking us essentially through your career so far, and for those words of wisdom at the end. If we've got any questions from the audience, please place in the Q&A box, and Dipendra will be happy to answer. So before we actually move ahead with the audience's questions, I just had a few of my own. And I wanted to ask, for myself and I guess for some of the people in the audience, what would you say really is the difference between your experiences working for a large organization and working for a startup or a smaller one, since you have experience in both?
Sure, that's a very good question. So I think looking at the way in which the order in which I worked for those companies, it was great working for a corporate early in my career because you get many of the training opportunities in terms of that their budget is much more extensive. So they can definitely spend more on training. They tend to run graduate schemes, which are nicer because you can be kind of onboarded with other graduates and you feel more like part of a community that are going through that transition from often uni to working life for the first time. And also the size of the projects tend to be much larger. So you could be working on many like multi-million-pound projects and perhaps getting exposure to those kinds of things early on. However, they also have lots of process, which for me, most of my roles were focused on R&D or research and development. And often when you're trying to develop something from the ground up or move quickly, I found sometimes working for a large corporate can be slow due to the processes that are in place, which are there for good reason. Whereas in a startup, you tend to be a bit more agile, so you can do things more quickly. Also, you're working in a smaller team, so it does feel a bit more like a family environment, for want of a better word. And also you tend to take on more experience quickly. So where I was working in the startup that I mentioned, there were different groups by discipline, like software, electrical, hardware. And although I was working in test, I got to learn lots of the other disciplines, which definitely helped me to get future jobs because I could show a bigger portfolio of experience.
Okay, thanks for that answer. We've got some questions from the audience now. The first one is, I guess, a bit of a general one, but I think quite important. So the first is, if you could go through your career again, what would you change and why? If you could go through your career again, what would you change and why?
That's a good question. To be honest, I don't think I would change anything. I think the zigzag nature of what I went through, as I discussed in terms of the success trajectory, due to the nature in which I did go through those experiences, led me to get to where I am today. I think the main thing I would emphasize in that journey is just to be open to those opportunities and just to network well from the beginning, so you have more doors open to you as you go through your career.
Okay, thanks for that answer. So I think, like you said, it's really quite important to network as you go through these opportunities. And I think from your presentation and from what you've discussed as being your journey so far, it seems like it's definitely made a difference. And just for the audience that's out there, it would be important to incorporate networking into your experiences as you go along in your career. Our next question is, how important are internships in your second/third year as an engineering student in securing a job post-graduation? Would it be difficult to land a job in the engineering industry without an internship experience? Would you like me to read that again?
No, that's fine. Thanks, Toby. So this is a very good question, and thank you for asking that, because I definitely fall into that same category. I think just to make you feel more at ease, I had no engineering experience whatsoever when I applied for my jobs post-graduation. So in my first year, I managed to get an internship working as a teaching assistant in my old college. And the second and third year, I worked at the university as a research assistant. And third year, I took off as a holiday because, let's face it, we all need a break after our degree. But no, I think the short answer is no, you don't need internship experience. However, any experience that you can show is obviously going to be beneficial. But to be honest, time and time again, what I've seen working in industry, of course, experience trumps knowledge as you go through your career. But initially, I would say it's more about competencies and more about how you are as a person and whether you've got the aptitude to fit into a team to pick up things quickly. And they know that for sure any smart engineering graduate is going to be able to learn quickly, is going to be able to pick up things. So if you can demonstrate those softer skills, if you can demonstrate those other skills that you might have gained through a sports club, through a university, society, through a part-time job, working with people, working with the public, working in a team, leading projects, doing volunteering. If you can work on those things, sell those things, make sure they're on your CV, make sure they're on LinkedIn, those will also help you. And as long as you can demonstrate those criteria about how you can work, don't worry too much about not having the experience.
All right. Thank you very much for that answer, Dipendra. I certainly echo that sentiment that developing those soft skills are quite important. So, being able to volunteer in different positions, for example, at an organization called Toastmasters, or a very good example is volunteering for the IET. Having that experience, if you will, to show your soft skills, because, like Dipendra said, most companies already know that as an engineering graduate, you're quite smart. So being able to show that extra bit of competency is quite important. Thank you very much for that, Dipendra. We've got one more question. It says, how much do you think the university you graduated from affected the job offers you received? I think this is a pretty important question, pretty good one. So
that's a very good question.
Yeah, how much do you think the university you graduated from affected the job offers you received?
I guess it's hard for me to assess that because I've not ever had direct feedback from any of the applications in which I wasn't successful, that it wasn't, due to the university that I applied or that I went to. However, being on the other side of things and actually interviewing graduates myself, personally, I would look less at the university they were from and probably more at the combination of their degree classification first 2-1, etc., coupled with the experiences I mentioned previously. So have they tried to use their summer holidays for taking part-time work, even if it wasn't in the job they're applying to? Have they been active in volunteering or other causes? I'd probably look at the combination of the two. Of course, the degree, the degree itself. So if I saw that, electrical engineering degree, that would kind of get you to the door of the interview. And of course, having a higher degree may influence that decision. But for me, it's the combination of having a good degree, but also marrying that up with the other softer skills gained from the other experiences we discussed before.
Thank you very much for that answer. We've got another question for you. It says, does taking a break from your career and planning to complete your master's or PhD affect chances of growth in your career?
That's a very good question. And whoever asks that, if you want to talk about that in more detail, then we can catch up on another forum. I, of course, consider that a lot, considering going into a PhD myself at this point in my career. And I think it's really a unique thing, and it depends on a number of factors for yourself in terms of, are you changing career disciplines, how you are financially, where you are in your personal life, etc. But I think as long as you can plan some of those things and you're comfortable with taking that decision, you'll be fine. Obviously, having the support from those around you. I guess more generally, talking from my own experience, I've taken 2 career breaks between working for the large corporate and the startup. I took off 9 weeks, and actually I had no job secured. I left the large corporate and decided to take a small holiday for 9 weeks, and I had a holiday, and in that time found a job. And then also at the back end of last year, I left my other job before Christmas and took off 3 months, got more involved with the IET as a volunteer, working with the team, Toby and Jason. And I then decided to pursue a PhD. So I've done it twice. I think it's good to take a break throughout your career, and you can kind of consider it as a mini retirement. Don't consider just retiring when you're 60. I think it does you well, both mentally and physically. And yeah, just take breaks, continue to revisit what you enjoy and where you're going. And I think that's the great thing about working in STEM. There's so many opportunities, there's so many new developments in tech happening all the time. As long as you're upskilling yourself, there's plenty of things you can go to, moving upwards as well as sideways.
All right, thank you very much for that answer. I really like the idea of a mini retirement, and we'll definitely be considering that. We've got no more questions for you at this time, but just to let everyone in the audience know, there will be a question and answer report that you can download afterwards, after the webinar is over. So we'll be sending that out to all the registrants for this webinar. Thank you again, Dipendra. And we will be moving over to our second speaker, Jason. Jason Lee is a co-chair, I believe, of our IET London Young Professional Network, an engineer, a chartered one at that, and he will be giving us a nice little presentation about his career, his work, and his journey so far. So, Jason, let's take it away.
Thank you very much, Toby. Great introduction and great presentation, Dipendra. Pretty hard to follow on to that, but let's give it a go. So just going to try to share my screen. You guys good to see?
Yeah, it looks good.
Awesome. So hi everyone, and great of you all to join. I think these series are absolutely amazing to help you young engineers understand what types of engineering is out there. And you will find that engineering is such a broad topic of area. Your career will range so crazily throughout your whole career and your timeline. And I'll talk about being a building services engineer, but you'll realize soon enough that what I do is also very broad, and there's so much things within being a building services engineer that encompasses being a building services engineer. I also talk to you about quickly on what I'm transitioning into as well, and what I'm doing part-time, and that's being a smart buildings consultant. Slightly different, but it shows how there are a lot of opportunities out there to do really whatever you want. The image behind you is actually one from the top of 22 Bishopsgate. Any of you who are in London know that that is the new tall high-rise tower in the city of London. And I was up there when I first came to London about 2.5 years ago, when this building was still being built and it was being topped off. So I was on the very top level with everything open as it was being built. I saw the generators, all the plants, all the engineering equipment that was on the roof. And at that point of time, I was the tallest, the person that was at the tallest point in London out of everyone. The Shard is the tallest building in London. However, the tallest occupiable point is actually on 22 Bishopsgate, and that's because the Shard has a bit of a shard at the top, but also because it's built on the lower area. So that's a quick fun fact. But really, I just wanted to run through the introduction, quick spiel on what it means to be a building services engineer, and a quick one on smart buildings, and just conclude on that. My first slide really is just an introduction about me. I didn't want to go too deep into it, but I was born in rural Sydney, Australia. I studied a Bachelor of Electrical Engineering and Diploma in Engineering Practice, a 5-year degree at the University of Technology, Sydney. I did, in between that time, I did a lot of volunteering in my spare time, such as with the IoT itself, part of a committee member. I've been a committee member for almost 5 years now, having lots of different varied roles. I was also a firefighter at the time, so it's great to do a lot of community stuff and be very involved in not only the engineering community, but also other communities out there. But just being a part of the engineering community really helps you get in the mindset, get around the people, get to be around with people who are passionate about engineering, just like you are. My first job was door-to-door sales, nothing engineering related at all, but really helped me get out of my shell, being a shy 21-year-old person. My first internship was at WSP, a large engineering consultancy, which I am still at the moment. But obviously this was WSP back in Sydney. I then graduated in 2016. I had the opportunity to transfer to London to work on some awesome international projects, to understand how engineering is done differently around the world. And you'll find that engineering is done very similarly across the world. The basics of engineering, which allows, if you're interested, an engineer to work anywhere in the world and do the same thing. So it's a great opportunity. And today, in fact, today was the day where I received my notice that I've become chartered. So it's a really great day today, and you can see I'm pretty tired because I've already gone out and had some celebrations with my workmates in the office already. But I wanted to dive straight into what it means to be a building services engineer. And the definition, if you go online and jump in, is your role as a building services engineer is to design, install, and maintain the services that allow a building to do what it's designed to do. What does that mean? So, but the way I like to say it is, think of a building as a human being, the body in its entirety, designed and created by the wonderful architect. Its bones are the structure that hold it in place and keep everything up, and it's the skin, its facade. But what is it that allows for the empty shell to be living and breathing? What really brings it to life? The organs of the body, right? The complex distribution networks that allow the blood to flow, the signals that go from A to B. This is what I think of when I think of building services in a building. And you'll see a really cool picture to the right side of you. This is an extract from a Revit model. It's a 3D model, sometimes called a building twin or digital twin. And basically what you see there is I've stripped out the structural components, the architectural components, and all you're left is the building services. And it looks pretty cool, and it is pretty cool. And And every single project that I work on nowadays is in Revit, is in 3D. And this is what me and my team do every single day. We work in the model, we design things that are visually really cool. So just a bit more deeper about building services engineering. The core services of building services engineering are really the mechanical, typically heating, ventilation, cooling, the electrical, typically supply, generation, distribution, and the plumbing, water supply and drainage discharge. That is the sort of core sort of services, and it's typically in the past it's always been known as the MEP engineers. And you always think MEP engineers, they do everything in terms of building services. And it is so true. As an MEP engineer, we have to understand all the services that go into a building. And it is incredibly complex, which makes it incredibly interesting and fun. There are other services and specialisms that come into the building, as you might think, you know, lighting, natural and artificial. You can get pretty complex lighting schemes and designs, which a typical building services engineer wouldn't have the expertise for. You know, security and alarm, fire detection, protection, escalators and lifts, ICT, lightning protection, building control systems, so much more. Really, building services engineer, the term itself encompasses all of this, any of the services that are within the building. Me specifically, I come from an electrical engineering background. So I started as an electrical engineer working on, electrical supply, working on resilience in terms of electrical supply, working on generation, power generation, generators, PV, distribution of electrics around the building. That's where I started. But quickly you expand your knowledge, and now I design security and alarm systems, fire detection. I understand very well lightning protection systems, escalators and lifts. And it's allowed me to just branch out to wherever I want. And what you'll find is a lot of building services engineers start somewhere. They start in plumbing, for example, but they find an interest in totally something else, totally something different, such as escalators and lifts. And then they spend the next 10 years of their career doing escalators and lifts, or doing something that they enjoy. But starting off as a building services engineer really gives you the broad and breadth of the built environment. And I think that's really cool. The day-to-day of what I do, there's a lot of different things I do, but breaking it down, learning and development, constantly understanding what's the latest developments in technology, construction methodologies, and not just my own industry, understanding of my own discipline, electrical, but understanding what my mechanical colleagues are doing, my plumbing colleagues. So I'll always be learning, never bored. I'm designing and building, so I am often designing using complex calculation sheets that you can see on the top there. That's me calculating the maximum demand of a really high profile project where I had to really dig down deep into the utilization, the resilience. I had to look really deeply into what the building is using electrically during the day and the night, what it's using during each hour of the day, and where most of the electrical supply is being distributed. Is it mostly going to HVAC? Is it mostly going to big pumps and whatnot? And why? Why is that the case? Why are they using significantly more? And how can we save that? So there was a lot of days and nights and weeks spent on that. You can see the next picture to the right. You can see that's typical Revit model, and more to the left and the bottom where I'm designing, creating drawings. And these drawings go out onto site where site engineers and builders actually look at it and say, that's how I'm going to build it. And the last one, collaboration, coordination. That is an incredibly important part of my role. I like to think the building services engineers are kind of at the center or close to the center of the whole process of designing and building a building. We work very closely with the architect, the client. We work very closely with the builders themselves when they're actually on site answering site queries. So we're part of the whole process, which again, is another learning path and is incredibly interesting. What we deliver, and these are the projects that I've delivered here in London in the past 2.5 years, and that's not a long time to deliver these 6 incredibly large projects and a couple of others as well. But obviously, I didn't deliver these from very beginning to end. But I was a part of a lot of the processes in between. We have a process called the Revit stages of works, and so I worked on stages 3 and 4 in particular, which is mainly the detailed design of all the services in these buildings. You got 22 Bishopsgate far onto the right. You got the Shard, which when I came here, it was just in its completion, and we were doing some fit out works. We were doing some final snag lists and queries from the constructors who were going off the site. The National Holocaust Memorial, which is one of my pride and joys, which I was very much involved in, and which got a planning approval about 4 weeks ago, right outside of Westminster. You can see there. So that's an incredible building, subterranean museum and memorial, absolutely wonderful. And Africa Institute to the top left there. It's in Sharjah, so the UAE. Amazing architects that I work with. You can see that it's an absolute marvel of architecture. In terms of services, it was very complicated because we just had to work very closely with architects to make it look visually appealing. And the data center in the center there, which I can't talk much about. But yeah, lots of very different projects, and I've had the opportunity to work on pretty much whatever I want. What I want to do now is I want to quickly showcase a really cool 3D model, which I almost work in the model every day. Revit models and 3D models are a thing that has really only come in the last 3 to 5 years. When I first started, 5 years. When I first started in the industry, Revit just started, and everyone just started doing 3D models. But before then, it was all CAD, 2D, and no one used to look at how, the 3D aspects. So let me try to share that now. Hopefully this works. And I'm conscious of time as well, because I often talk a lot. Let's see. Can you guys see the model?
Yes.
Oh, good. So this is a 3D model of I can't really tell you what project it is, but it's NDAs and whatnot, but you can see this is what we call a federated model of all these services, architectural, structures, all the services involved. And most of these in color are the building services. Let me zoom in here to show you one of our plant rooms that we designed. To give you can see this is all, remember, all the colored stuff of what we design, what we calculate. Every one of these pipes that you look at, every one of these pipes, red, blue, well, that's probably beam, these orange cable trays, we have to size, we have to understand what's on them, we have to understand what's the load on them, we have to calculate. You can also see all of the large equipment, that's our stuff as well. You can also see how much detail that we put into these models. These models can vary in detail very often depending on clients' requirements. This is one of the more detailed models, and you can see all the details into the the fixtures of them, and the pumps and how individually how they all work. And so what we do is we build this federated model, we send it out to site, and people actually put on this particular project, we're utilizing technology in a really cool way. People are putting on these VR goggles, they connect it with this model, and they can actually walk around with these VR goggles and imagine what the space would look like. So they might step into an empty room and say, what's supposed to be in here? They put in the goggles and they say, oh, that's there, and the builders can actually visualize what's there in real time and real geographical space to accuracy of I can't remember what it was, but you know, millimeters. Well, probably not millimeters, but centimeters. Yeah, because of satellite geographical, and they can do that. So that's a quick share of some of the models, and you can see it's complicated. And this is if you imagine again, once how far I just zoomed in there, that's just that section. But we and our team, we designed the entire building around that. So let me go back to the presentation. Let's go and hope this works. Okay. So if we can see the presentation again.
You're good.
Good, great. Okay, so that's the Revit model showcase. So that's the end of MEP. What I've recently started doing in really the last 6 months is I've been transitioning into what we call the smart buildings thing. This is very new. This is maybe in the last 2-3 years, where this is a brand new, almost a brand new industry, or that we're creating. It's a very new team. Very much so still engineering related, but also very much so strategy related. More so sort of technology, the use of you know, Internet of Things, how we use data, how we gather data. So engineers are very good for this as well. But basically, smart buildings, and what we do is we ultimately want to enhance the user experience by understanding how people want to interact with the built environment through technology. We also want to be super efficient through automation. And this is a really cool one. And I think a lot of engineers were very interested in this, because it's really about understanding how you can gather all the data that a building can provide you. This is absolutely enormous. Think about, you know, basics such as occupancy data, how much people are in a room, or you can gather, you know, a pump, how often a pump is turning on and off. And then you can link them together. You can link these data points together, such as how often there are people in the room, or how many people are in the room, to turning on or off, or you know, turning the speed of a fan or whatnot that might cool or heat the room. Now, at the moment, this is done, you know, quite separately. You might have a special system that does you know, the heating and cooling, that interacts with the lighting, or you might have something, you know, it's done quite separately. But what we're trying to do is have a building that can actually understand all of these data points, and be able to interact in ways that we've never thought about. You know, how does the water pump, on when you turn on the tap, how does that interact with you know, how hot the water is being heated in the hot water tank? I don't know, it's just a random example. So what we do is we strategize at a very high level, very early engagement with the client, to understand really what are the latest technology, what are the latest trends in the built environment. The client often asks us really high level, broad questions, sometimes philosophical. What are the latest trends in building technology? Should we implement public Wi-Fi? What kind of data do I need to help understand my users, or how do I gather that data? And so that's what we do. We look at, you know, the trends in the industry. We develop, and you can see that on the top left image. That's understanding the trends compared to what they can really implement now, what they might not be. And this could be anything from what's reality all the way to the outrageous. And then we develop user journeys. That's the top right there, where we try to understand, you know, the different types of people that are working and living in the building or in their building, and how we can help, you know, help their pain points. What don't they like? You know, they cycle to work every day, and they're all sweaty, and they, you know, what do they, yeah, what kind of things that can help them. And then we help develop actual solutions, whether that be a mobile application. That's one of many hundreds of case studies that this process can sort of attain. And so just concluding, and I know I've gone a lot over time, but just concluding, some of the advice I give you, you know, a career in building services engineering will be incredibly varied and full of opportunities. You know, I'll just say a couple of general things of advice. Say yes, whatever it is you choose to do, whatever type of engineering, whatever type of STEM career you choose. Get out there, give it a try, be proactive. Make sure everyone knows what you want to do. You want to work on this building, you want to work on that. Yep. So set your sights far, not only in the type of work you do, but role in different industries, roles and titles. Often you create your own role. This smart buildings consultant role is actually almost brand new, and it's almost a role that myself and the small team created in the past year, 6 months. It's because something we want to do, and we think is an area that we can work in the market. And embrace the exciting unknown, because our careers will be so varied and full of opportunities. You don't know what's going to be out there, but you just have to trust that whatever you do will be amazing, and you will, and it will be. So yeah, any questions, and apologies to the rest of the team for going over time.
No, it's not a problem at all. Thank you so much for that presentation, Jason. I can say personally that I learned quite a bit from it, and I imagine that the rest of our audience did as well. So we'll just wait for a few questions to come in. But before we get any questions from the audience, I would just like to ask one specific one. So how has your sales experience, if it has at all, how has it helped you in your career as an engineer? So you mentioned you had a sales background before you graduated as an engineer, and just to find out how it's actually helped with your career.
Oh, okay. Sales background. I was trying to go. Is that what you meant, Toby? So
yes.
yeah. So I did about 1.5 years in door-to-door sales. Absolutely. Yeah, it was at the time. I was the classic engineer, I would say. Kind of really technical, loved my maths and science, didn't talk a lot, just kind of worked a lot. But in fact, what you might not realize when you start working, and everyone keeps talking about this while you're at uni and when you go networking events, is these soft skills, and I'm using the word soft skills, is so important. And I'd say sales helped me build a lot of those communication skills that really I probably would not have attained anywhere else. But I would like to also say that these soft skills, such as communication, you can develop them almost anywhere, and it's really about understanding what they are, and also then committing a process or committing yourself to learning about those soft skills. And how has it helped me in my career? Absolutely, in almost every way. From networking. Networking was how I actually got my job at WSP. Just talking at an industry event, at an IoT event, in fact, to people who just happened to be the people who were interviewing me for this job. And so if I wasn't able to I don't know, speak as well or so fluently or easily, maybe it wouldn't be where I am now. And also talking with clients, architects, everyone, communication is just a key skill in general. So thanks for that. Great question, Toby.
All right, thank you very much for that answer. We've got another question on here. Let me see. So to both of you, how much reading do you need to do on a weekly basis in order to keep up with day-to-day work and to ensure that you're up to date with trends in your industry and trends in technology? So how much reading would you need to do?
I'll jump on that first, if that's okay, Dipendra. Very good question. How much reading do you have to do? The real answer, and my answer is, I would like to say the word none, but the reason why I say the word none is because what you do as an engineer, it shouldn't be just a job. It should be what your life. It should be part of your life, right? So you shouldn't be going out to look for a book or something to read about what you do. You can, and that's really good to do. But in fact, if you're someone who just naturally enjoys engineering, or you subscribe to newsletters or newspapers, you're already doing that reading. And that if you want to count that, yeah, sure. Make sure you subscribe to engineering newspapers, newsletters, online articles. These days, it's all about podcasts. Podcasts is really cool. Yeah, reading books, watching videos, and yeah, that'd be my answer.
All right. Thanks for that answer, Jason. Dipendra?
Yeah, sure. So without sounding like a plug for the IET, of course, the IET is a good way to keep up to date with current affairs. Their monthly magazine covers everything outside of your industry and wider field. Aside from that, there's also free sites like theengineer.com, I believe, which has it's like a news site like the BBC, which is always good to go on to check up on things. I guess it depends on your industry. So for mine, because I tended to work more in the research and development side, often the projects and the nature of the technology may change every 6 months. So there would be a bit of reading required, but I normally used to go off of the more senior people within the team to guide me on what to read. I wouldn't necessarily say it was anywhere near the volume that you might cram for an exam at university. It may be certain public peer-reviewed papers sometimes, which might be really useful for what you're learning. And otherwise, particularly in the companies that I have worked in, some people just bring in old textbooks, and those serve as good things to go through. Of course, Wikipedia, but not when you're writing customer reports. Yeah, most of the learning you can find online. And to be honest, if you've done a degree, you know how to learn. So that's one skill you already have. So you just apply that in the way you need to.
All right, thank you both so much. So from what I can gather from what you both said, to learn on the job, you need to go beyond the reading, essentially. So like you can read, but you can also go through other forms of media as well. So you have podcasts, websites, videos, and things like that. And Dipendra, thank you for mentioning peer-reviewed papers as well. Because usually as students, undergraduate students as well, you're more exposed to textbooks. But as a graduate student is when you really see the importance of peer-reviewed publications and things like that. And Dipendra, thank you for also mentioning going to senior colleagues as well. So if you're in that position where you have those senior colleagues that you can meet to ask for advice on what you should be focusing on, then I think it's important to do. So a question for you, Jason. Got a question here that says, typically, which Revit stages would you work in? Now, this is not something I'm familiar with. I don't know what that means. But yeah, which Revit stages would you work in?
Yeah. You kind of have to be in the construction industry to really understand the Revit stages. Typically, I'll be working typically in the stages 2 to 4, or maybe 2 to 5. Those are my key stages. So Revit 2 would be about talking about concept, helping design the engineering concept, and all the way up to 5, where you are sort of transitioning to the actual site. You're reviewing, site drawings and approving them. So that's typically where I would work in. But I have worked from all stages, really, from 1 and even before 1, and that's where the strategy work comes in. The smart buildings, which is before then, and also after 5, where practical completion, operation and manuals, and yeah. But typically from the 2 to 5.
All right, thank you very much. I hardly understood any of that, but I'm sure the person who asked that question does understand that. So thank you both for answering these questions. In just a minute, maybe 30 seconds each, do you have any parting words for our audience? Dipendra, you can go first.
Sure, thanks. I guess first thing is thank you for taking out your evening to join us for this event. And the second thing is you've now increased your network by a factor of 2, perhaps, but with everyone on the call or more. So yeah, make sure you connect with them if you're not on LinkedIn and platforms like that. Get onto those platforms and connect with people and start conversations. You never know where people's careers are going to go in the future. So you may be talking to future CEOs and other people at the top of their field in 10 to 20 years time.
All right.
my last words would be, yeah, engineering is just so varied. When you get your first job, don't think that that's all you have to do. There's so much out there, and just chase for whatever you want to do, what you enjoy.
All right. Thank you.
Thank you, everyone.
Thank you to our wonderful speakers, Dipendra and Jason. I'm sure a lot of people have learned quite a lot from you this evening. And to the audience, thank you all so much for joining us for this webinar. Please feel free to contact us for more information on how you can join the IET, how you can join the Young Professionals Network. We have our social media right on the screen there. So Twitter, Instagram, LinkedIn, Facebook. You have a few emails there. You can just shoot us an email, ask any question. I believe Dipendra also put his email in the chat as well. So if you want to go ahead to contact him afterwards, please do. We'll also be sending out, as part of the question and answer session, we'll be sending out all the questions and answers as well from this webinar. Again, thank you all so much. As previously mentioned, there will be more of these events in the future, so please stay tuned for notifications on that. Have a wonderful evening, everyone. Thanks for coming. Take care.
Take care. Thank you for hosting, everyone.
Thank you.
Thanks, bye.